it looks like.
Yeah, but I think there's kind of a consensus that Replit is a little slow. At some point, maybe near the end, or at some point, we could maybe point you guys to a couple IDEs outside of Replit that you guys could do Java coding in. There's a lot of options. I have a few personal favorites, but yeah, there's actually a lot of good options for Java.
I'm curious now. Which IDE do you like coding in? Please say Eclipse.
I'm gonna say Eclipse because IntelliJ.
It's also so slow to boot up.
Yeah, Eclipse is annoying. IntelliJ is like my favorite, but that one you need a license for. So yeah, Eclipse is like after IntelliJ, that's the best one, and it's free and it's powerful and it's fast, and I used it for a long time.
It's like most of the people we're waiting on are still not here. Should we wait a little longer, or do you want to get into it?
How many participants do we have? Let's either give it until we hit 10 people or at 2:05. Does that sound good?
2:05 is good, yeah.
All right.
In the meantime, does anyone else have any questions with anything that we went over from last week? You can feel free to either, unmute yourself and say it, or just type in the chat and I'll try to answer questions or any confusions that you might have had from last time. Michael, do you want to show some other slides from this content and see?
There's another person. Does everyone maybe click yes if you got a chance to mess around with Replit over the last week, or got to mess around with using scanner and random to make a program. You can just type yes in the chat, or you can click yes in the participants tab. All right, awesome. All right, so I think we could get going just about now. Yeah, I think we can start. So let me present for a sec. So hi everyone, welcome back to Programming with Java with Jenko. I'm Michael.
And I'm AJ. We're both rising seniors at Bergen County Academies.
And last time we left off around here, just like as a quick review of everything we did, we learned like why is Java a cool language? We learned keywords, we learned variables. We messed around with stuff a little using the system.out.println, and we learned how to get user input and also make random numbers, and how to import those functions. So last time we left off, we got to messing around with making a program that would use scanner and random. So I saw in the chat a couple people did get to try making something like that. I'll just bring up a little sample of what you could have done with that. So here's some code over here, and we can walk through this really fast. So you see here, if you remember, this is the code used to make our scanner, and this is the code used to make our randomizer. So I put that right at the top.
And then we, print out to the console, letting users know enter a number. And then we sent with int, right? Because you have to declare the variable type. We set this int num variable to whatever the scanner takes in from the console as the next input. And they're expecting that to be an int. So if instead when we run this, we enter some string or just a bunch of letters, it would give us an error because we're expecting an integer.
Mhm.
Then we also have the random module that we've imported, getting us a next integer as well in here.
Yeah.
Saving
And so
that
now that we have these two numbers, we can tell our user, well, your lucky number is the random number. And you see here, we put together the string and the number by just putting a plus here. So I'm not sure if we went over that last week. This is called concatenation, and it just means putting together two things all as a string. So by doing this, we can turn this integer, we can make this integer pretend it's a string right here. And that lets us say your lucky number is, if this number was 7, we could say your lucky number is 7.
Concatenation
And then down here, we mess around a lot with it. So we say, here are some more lucky numbers, and we might say number plus the number plus the random number, the number minus the random number, the number times the random number. And you see here, we put together a lot of stuff by swapping between these integers and these strings. And you see we put these numbers in parentheses, so it doesn't think this plus is like putting together more strings, if that makes sense. So if we run this, we'll see.
The quotation marks and commas are, again, just for formatting, so they are just plain text strings that we're putting out.
Yeah. So if it tells me enter a number, and that's where it waits here, it's waiting for my input. I could say 5, and it tells me my lucky number is 9. So it gives me some more lucky numbers. So in this case, it would give me 14, -4, 45, and 0. Yeah, Kevin?
I see you were talking about the use of integers, and I can't remember what you told us last time. When you get to that last one where you have num divided by random, is that going to give us an integer answer, or is that a floating or a double? What kind of result?
Good question. The way it works in Java is you're actually right. It will give us an integer number because we divided 2 integers. But let's actually try a different experiment. Let's try, I believe this is a next double for scanners, right? So let's try making this a double instead of an integer. And if we run this, I'm 99% sure this is gonna work, I'm sorry. But this is a really good question. Say we enter 5 again. You see, okay, well, 1 isn't the best number for this to happen with, but you see it's all coming out as doubles now. In Java, when you operate with a double and an integer, it will always give you a double. But if you operate with 2 integers, it'll give you an integer. So in this case, when num was an integer and this was an integer, it was actually giving us an integer answer. But now that this is a double, it's giving us double answers. And you can see it's a double because it has the 0.0 at the end for everything.
Thank you.
If you say you have a double and you want an integer output, if I run this one more time with a number that's like more prone, let's just try that again, and hopefully I don't get 1 again. And you see actually now it is giving us that whole thing. If you didn't want that, if you always wanted an integer answer, I believe, I've never explained casting, but there's a thing in Java you can do called casting, which is where you ask it to pretend that one type, something is a different type than it actually is. So all you have to do is just, say you wanted num to pretend it was an integer right here. All you have to do is put the word in parentheses next to it, and that'll have it pretend it's an integer for that one moment. So if I run it again.
And we're pretty lucky that we're in Java, but if we were in, say, Python, this part right here would give us an error because we're trying to put together a string and an integer or a double, whatever we make it. In Python, we would have to call this like string and then wrap that also
Yeah.
But Java automatically does that for us.
Yeah, so a lot of other languages would be awkward with it, but Java's good with it. And you see, because we did this cast here, because we told Java, this isn't a, pretend just for a moment, this isn't a double, pretend that it's an integer. Because we did this, you see this comes out as an integer. So anyone, we actually went to a lot more topics there than I expected. Anyone have any questions about casting, about integers and doubles, about anything?
You can cast any variable type as any other type.
There are certain things that are like going to be kind of incompatible. You can't like cast, I don't think you can cast
Like a string to
a string to a Boolean, for example. Or like when you get to like, you can't cast a scanner to an integer. You could try actually, but you can't. Because technically it is still just different types of things. And you could cast to these object types if you wanted to, you just can't. You could try, you just can't. What is interesting, you can cast integers to characters because in the end, characters are just, if you know what Unicode is, it is, characters are literally just numbers and they're told like, okay, this number means this character. You guys could search that if you want to, why characters and integers are pretty much like comparable. And that could teach you a lot about how, you know, code, like, there's a lot to learn about that. We're not going to focus on that now, but there's a lot to learn about characters and how they work.
And again, we are pretty lucky in Java for that because characters are denoted by single quotes, whereas, you know, strings are denoted by double quotes. But I think in Python, strings are both double and single. So it is pretty in Java, I think.
Yeah, they work really different depending on, everything works different depending on the language, but Java's pretty good with everything. All right, so again, no questions, everything makes sense. We can move on. Awesome. So yeah, so we've learned how to use scanners, we learned how to use random, all that makes sense. But let's go on to a different subject. A while ago, we talked about Boolean variables and we said true or false. What does that mean? We're going to explain it in a sec. Well, now we're going to go over what a Boolean variable is. So let's look at all this and let's start discussing what any of this means. So you see here, we say Boolean A is true, Boolean B is false. Then we have all of these crazy like symbols next to them, and I have true, false, true, true. What does that mean? We're gonna learn what Boolean algebra is now. And what that is basically ways, it's all the different ways Java can use the fact that these could only be true or false to our advantage to do something called logic. So I'm going to go into Replit and I'm going to show off the various different kinds of Booleans and Boolean operators. So let's make two Booleans right now. Let's make Boolean A equals true, semicolon, and Boolean B equals false. And if you don't remember from last week, that's fine. Booleans, you can think of almost like a light switch. They have exactly two positions they can be in. They can either be true, which is like on, or false, which is like off. So with that knowledge, we can do a lot of cool things with Booleans. So we have a lot of options about how we want to control them. AJ, do you want to show off some of them?
Sure. So still a little bit more on the theoretical side, we have these different symbols. So if we go back to the slides, or no, we can honestly just do it right on here. So what we can do is we have different symbols meaning different things. So for one thing, we have or, and this kind of works just like English. So A is true, B is false. If we say, I'll do system.out.line, because we'll go into if statements later. If I say A or B, if I say true or false, then that would equate to true because one of those are true. And we'll try running that just to prove that.
Yeah.
On the other hand, if we say something like, fine, I'll just set that up. If we say something like A and B, if we say true and false, then that's a false statement because we need two things to be true in order for it to equate to true in the end. I'll run those once we're done putting everything on here. We also have something that means not. So in this statement, we have A and B, right? We have two conditions, true and false.
You've got
because one of those are false. Oh.
Semicolon.
Thanks. Because one of those are false, the whole thing equates to false. But we can undo everything by having this thing called a bang or not symbol, which is just the exclamation point. So if we say not A and B, it gives us the reverse of whatever it would have been. To equate this part first, so it would be true and false, which is false. Then you'd see the not, which negates that. So it would actually evaluate to true in the end.
So the way to think about like trying to remember this, if I told someone, if I tell someone I woke up at 7 o'clock or I woke up at 8 o'clock, say like I really woke up at 7 o'clock this morning. If I said I woke up at 7 or I woke up at 8, then this would be true, right? Because if this would say Boolean A was I woke up at 7 and Boolean B was I woke up at 8 and I really woke up at 7. If I tell someone I woke up at 7 or I woke up at 8, this would be true. Even though I didn't wake up at 8, one of the two is true. So you think, oh, well, yeah, that's true. But if I told someone I woke up at 7 and I woke up at 8, I mean, unless I woke up and then I fell back asleep and then I woke up again, who knows? Unless that happened.
Kind of like that analogy, so I'll just go through and show
Yeah, I guess. So, yeah, unless I didn't wake up at 8. So even though I did wake up at 7, I didn't wake up at 8. So this whole thing is false. That's kind of what you want to think about. And means everything has to be true for this to be true, or means anything can be true for this to be true. So yeah, Kevin?
It just means reverse that, so just negate it.
Yeah.
Thank you. Two things. Those are two
Pipes.
symbol. Okay, great.
So if you can't find the pipe, press Shift. It's in the top right of your keyboard, right below the backspace, I think, for most keyboards. And you, it should be right next to this slash. So if you hold Shift while doing that, you'll get this pipe. If you can't find the pipe, just search out pipe symbol in Google, and you should be able to find it.
Okay. Then one other thing with the not, is it? Do you do the not for the whole expression, or could you move that not immediately before the 7 inside the parenthesis?
Yeah.
And just negate the 7, and so it would be not 7 and 8.
Yes,
yeah, perfect. That's exactly how it would work. So if we got rid of these parentheses, this would turn into not 7 and 8.
Because 8 is already false. So, so it would be true and not false, which is true. So then you have true and true, which gets you true. So yes.
Very good.
Yeah.
Thank you.
So the way, basically, I think the best way to think about Boolean expressions is sort of like imagine them in your head. Like when you're coding, we're going to end up with less weird things than 7 and 8. So the way you could think about it in your head is just say it to yourself. Say, well, what am I trying to say? Maybe I'm trying to say, I did not wake up at 7. Then you just think not 7. Boolean statements are sort of, the goal of them, the way they're made, is so you can say them to yourself and they'll make sense. So always try to plan it out to yourself before you write it. Planning and readability is like one of the big things I want to keep reinforcing because it's so important. Plan out what you're going to write so you're able to look at it and understand what it says, and you're able to plan out before you start coding and you don't get like lost or anything.
And we will go into how this is all applicable and how it works in the context of actual programming, and just once you go through just these basic symbols. We just
So again, does everyone understands how or works, and not works?
All right, the last kind of important thing that we should go through is the equals. So this can get very confusing for beginner programmers because we like using just one equal sign. But what we have to remember is one equal sign means assignment. So, we use one equal sign here to say 7 is equal to true. But when you're comparing two values and seeing if they are equal to each other, we use 2. I like to think of it like a scale. So if there's one equal sign and another equal sign, and we're trying to tip the balance, which is how I think, oh yeah, we have to use 2 equal signs for comparison. So if we say 7 is equal to 8, obviously that is true and false. So you cannot have, I woke up at 7 is the same thing as I woke up at 8. So this would negate, this would mean it is false.
So that's just checking. Yeah, so that's basically it. The opposite of it is not equals, which is typed exactly how you think it would be typed. 7 not equals 8. And that's the opposite of equals, and it's saying, well, is 7 not equal to 8? And because 7 is true and 8 is false, 7 is not equal to 8, so that's all true.
Mm-hmm.
And then there's a bunch of others. 2 others you might, there's a lot of ways to use them. And there's ways to use them outside of just Booleans if you want to create a new Boolean. A good example, say I have int number equals 5 and int bigger number equals 50. Sorry, it just broke from me for a sec. Bigger number equals 50. Then what you could do, for example, you could still have these equals comparisons with them. Let's actually get rid of the Booleans for a sec. You could still have these comparisons between them. And if you see when we run this, it'll give us false true because 5 is not equal to 50. So it'll tell us this is true, this is false. Another thing you could do with it is check if they are greater or less than each other with just the greater than sign or the less than sign. And in the same way, you also have the option of checking if they're greater or equal or less than equal to each other. So these are all the ways. These are ways you could apply. This actually creates a new Boolean for you. So even though we're using 2 integers in this, it's still going to produce a Boolean for us. So these are ways you could create, oh, and I forgot all my semicolons, which is not a good thing. So if we ran this without me forgetting all my semicolons, it'll tell us false, true, because number is smaller than bigger number. So any questions about how all these ways of turning 2 integers into a Boolean works?
Yeah, if I may.
Mm-hmm.
So when it comes to the greater than or less than,
Mm-hmm.
we only use that symbol one time.
Yes.
As opposed to equals, where you have to have 2 equal sign if you're testing them.
Mm-hmm. So remember, the equals is there because we need to make a difference between this 1 equal sign for assigning something to a variable and the 2 equal signs for comparing 2 things. In any other cases, 1 equal sign is enough. Yeah.
Okay. It's just that with the or and the and, both of those duplicated. In one case, the pipe, and in that case, the ampersand.
So in that case, I think that's just Java making the executive decision to
Fair enough.
do whatever. Yeah. I did not
It doesn't
create
all
Java.
have to make
I
sense.
apologize.
It all doesn't have to make sense. It just
Yeah.
is.
We could go invade the HQ,
Oracle?
the people that made Java, Oracle HQ, yeah.
All right, so if we're ready to move on, typically we don't use, if we can go back to the slides, typically we do not use, if our Booleans and just like print statements. We typically use them actually to program and control program logic and program flow. So this can be accomplished using if-else statements. Actually, I'm also going to screen share just so that I can show one of my repos that I've made. So right, we're here on the if-else. So the way this works is we have 3 different ways you can go to like kind of control the program flow. We have if, else if, and else. So this is the practical use for Boolean algebra. This is why everything we've learned is really applicable and important. So if runs the code if whatever's in the parentheses is true. Else can follow an if, and it runs the code if the if doesn't happen. So I'll show why we have else ifs, because it is something that I think trips a lot of beginners up. So we have this rebel here. So we have the string called hello. This is, a 5-letter string, and it says hello. So we have here, if string equals hello, then we're going to say hello to you too. Obviously, this is true, right?
So the first question you might ask is, okay, well, we just had equals equals. Why do we have dot equals now? The best way to think about it is because remember that int and Boolean, all those things are lowercase. They're not objects like string is. This is a while ago I said, well, string is different from everything else. This is where that comes into play. Because string is an object, without going into the crazy explanation for it, because it gets kind of complicated really fast, and I don't want to subject you all to that torture. Because string is an object, whereas int and Boolean are what we call primitives, they get stored in different ways. And because of that, if you use the equals equals between 2 strings, it'll actually randomly just not work. That's the way you can think about it.
Again, that is a topic for later, but yeah. That is
so the way you can prevent that is by using the dot equals and then putting what you want to compare it to in parentheses. And I know that's like another crazy, like different format for doing it. But you just have to remember that if it's a string, if it's a string or if it's any object, you use dot equals. In any other cases, you can use equals equals, and they're equivalent in all other ways.
Thank you. Right.
Yeah.
So, so this would equate to true. This is just like in Boolean logic, how we have true and false. This is pretty much the same thing. We're just giving it something to compare now and something to give us and say, oh yeah, this is true or this is false. This is obviously true. So this if statement, what's in the body of it, what we indent inside, will run. So obviously, see that it says hello to you too. We also have another if statement, which says string.length equals 5, which is obviously true because hello is a 5-letter word. We print out that's a 5-letter word. I printed out 6 because I just changed it, but so it is a 5-letter word. However, both of these things run. If we had an else here, what happened is if we run this, only one of these would print out, the hello to you too. Obviously, we know that this is a true statement, but we're saying else. They're saying, if this is true, run this, but if it's not true, look at the other else ifs. So typically we have if, a bunch of else ifs, and then one final else. So let's say an else doesn't have a condition, because else is the catch-all. It's kind of like if it's just this one netting, and then if else are these other different types of nettings to protect it. But if everything falls through, then the else statement is there to catch it. And you don't always have to have an else, but typically that is how we structure our code. If, bunch of else ifs, and then one else. So if we have else, let's just say, I think I copy pasted it, great. We'll say, I don't recognize that. So let's say hello was some random keyword smash, right?
Yeah.
Does this equal hello? No, so it would fall through and check the else if. We'll say, does that string length equal 5? No, so we'll go just down to the else. So if we try running that, obviously I don't recognize that would print out. let's save some time.
Yeah.
Again, just one more note is that, let's say it is just A, B, C, D, E, right? If we have this also 5-letter string, then we have the first statement. So the program checks, is this true? And we say, hold on, that's not the same thing. So we're just going to check the else if. But then because this gets true and we say, hey, that is a 5-letter word, we won't even look at the else because we said, oh, that's an else, that's our catch-all, but we've already caught it here. So we're just not going to look at that. Same thing with this. If we did have hello, once it evaluates this, our computers won't even look at the else and the else if because it'll say, hey, we already caught it once. The rest of this is just saying, if this isn't true, we'll go here. So because hello catches it once, we will not fall down and even look at the else and else if. So if we run this, we'll see that it gets caught here. And then only the that's a 5-letter word will print out.
So yeah, the way you could think about it is if is just asking if something's true, and else looks to your last if and says, well, if that wasn't true, let's do something else. If you actually try getting rid of the else in the second part, no, so the else if, like the else in the else if. So you have like, wait, can you actually, I don't have access to that REPL actually.
Here,
Yeah, so say you got rid of the word else in the second part, right about, yeah. So what would happen here? So what's interesting, say that Sterling thing was like, what's interesting to note here now is that that first if statement is now completely disconnected from everything else. What's important to note is like else only applies to the last if statement right before it. So it doesn't check to see, it doesn't ask like, oh, what was the if from like, what was like the fifth last if? No, else can only check for the if that just happened. So in this case, that first if statement, like if star equals hello, that's going to occur. Actually, if you go back to the word hello, AJ.
Mm-hmm.
Yeah. So it's going to tell us hello to you too, and that's a 5-letter word. So it looks at that first if statement, and that's good. And then it looks, there's no else statement, so it keeps going. It goes to the second if statement. It says stir length equals 5, and it says, oh, that's true too. And then it completely ignores the else statement afterwards.
So if you think about it in terms of like groupings, these two would be grouped together and this one exists independently. If we had an else here, all three of them would be grouped together.
Mm-hmm.
And if we had, let's say, if, it kind of starts a new grouping, just like Michael said. So if we had an if here, and I had, something, and then we had this grouping, then it would be this grouping here, and then this grouping here. Another thing is that else if and else cannot exist on its own, again, because like Michael said, they're attached to ifs. So if is always necessary, but else ifs and else you don't need to have, but again, they're usually typically used to, again, have a little tighter control over the program flow.
Yeah, so question?
If I may. So it's when looking at lines of Java, if I have an if and then I get a close brace, I won't know if that if is really done until I get to the next line to see if it's an else or if it's something else, so to speak.
I don't think we mentioned the braces, yeah. So if statements have these braces, and those braces define the scope of that if statement. It's telling you this is where the if statement exists, this is the entire range for it. So if we put more things between those curly braces, those would be more commands for the if statements, and that'd be more stuff that would be skipped over later on. Like that would be more stuff that would be skipped over if the if statement didn't happen. Right. And then the way you could think of it is the else statement looks for like the most recent if statement, and it should come right after that closing brace for the if statement.
In fact, sometimes
Does that answer your question?
Like
I think it does. Yes.
It's a weird, like I don't like this style, but people do group it like this to kind of show a little more visually how everything is connected. So you'll see that it kind of follows in this direction. But again, it's all pure personal preference.
Okay.
One more thing we could note that's kind of important to remember. I just used the word scope to define if statements. One important rule about anything that involves these curly braces is the word scope. So what that means is so AJ just defined 2 variables in that if statement. And then that if statement ended. That curly brace just ended. If she tries to print out a variable from that if statement somewhere else, you can try running it, I guess.
Take some time.
So it'll tell you the variable a, that doesn't exist, cannot find symbol. And you might ask, well, we just defined a over here. Shouldn't it exist? When a closing brace happens, Java just, it gets rid of all the variables in that brace as if they never existed. Whereas if AJ defined those variables outside the brace, then she would be able to use them inside the braces. Because she's defining them inside, they stop existing once she gets out.
And even though both of these are true, it's true. So theoretically, we think, hey, like we do define this because this does enter into this code block. Like Michael said, it just stops existing once we hit this area.
Yeah.
Like everybody, Java does this for us. So again, we are lucky we're in Java, but you can see with indentation and with these braces, like where things exist. So like Michael said, I'll try moving these outside. So I'll move just A because, and in this case, we do have access to this A in the statement. So if we run that, you'll see that we do print out 8. Because this is an else if, right? So it wouldn't even look at this because this gets caught. But again, if this is an if, it would catch both things. That case. That's a 5-letter word and 8.
Yeah. And you might ask, why does Java do this? Basically because if, say we had it the old way we had it, if we did the word A, B, C, D, E like we did before, then it would break no matter what. And Java just doesn't want you to get into situations where you might make code that could break because of if statements. That's one of the leading ideas behind it. It doesn't want you to write code that is going to break because of these if statements and these curly braces. So it just does it like that. I don't, it's a little annoying, but it's overall good. It doesn't want you to get into situations where code is going to stop working because an if statement got missed.
Maybe you'll have more practice.
So now we can go on to some other things. So we just explained what an if statement was, and now what that allows us to actually have a lot of more control over our code, because we can use Booleans to decide whether or not something is going to happen in our code, which is really, really powerful and really, really cool.
We'll also be using the word condition to describe those things. So again, if we look back at here, string equaling hello is a condition because we're only running this under the condition that this is a true statement.
And remember, you can put anything that is a Boolean, you can put in there. So if I made my Boolean A equals true, you could put A in there. You can't, so you could put anything in there that is a Boolean. That's your only limit for it. So you could pretty much do anything as long as it just involves a Boolean. And remember, since you can change Booleans from false to true at any time, you have a lot of control over what is going to be true, what is going to run, and what isn't going to run.
But they do have to be Boolean. So before we had 2 Boolean statements in here, the computer would evaluate it and say, oh, it's true or false. But again, they have to be Boolean. So B would run because it is a Boolean. But A, if that's just an integer, it would say, wait a minute, we're not expecting that. We have no idea what that's supposed to mean. I guess I don't have to demonstrate, but we're running that anyway. Yep. So let's hold on. That's integers. Oh, I guess integers cannot be converted to Booleans like we went talking about last time. But yeah.
Anyway, so we
But you
can go
could have
on to,
cast it. Could you have cast it as a Boolean?
Actually, I think Booleans are typically represented as 0 or 1. So I'm wondering if we did make this 1, if it would let us. It does say it's incompatible types, but let's actually see. I don't know if we can cast to a Boolean, actually. I'm not sure what that would be. Michael, do you have any idea?
I'm actually not sure.
Yeah, I don't think you can cast.
Well, you wrote int b equals false, so that might be an issue.
Right, right.
So you have to remember, when you're changing from like an integer to a Boolean, you have to remember to also change the type it is.
Yeah.
So yeah, it's going to tell you
Yeah.
int cannot. Yeah, so it'll try to automatically cast stuff for you, like in there, but it can't do it here.
Mhm.
A lot of the time, it will automatically try to cast stuff for you. So in this case, yeah, we can't go from an integer to a Boolean. Can I share, AJ, if you don't mind?
Yep, go for it.
All right. So we can talk about the next section. Oh, it's not letting me share screen. That's weird. There we go. We can talk about the next section, which is actually, AJ, do you mind sharing for a sec? I just need 1 second, okay?
Yeah, sure.
Awesome.
So again, like we're just going to keep using Booleans and Boolean logic. So while statements are their extension of that, but they're a lot cooler, I think. And Michael will get into that. Michael, is the screen sharing working for you? If not, I can start going into while, and then Michael can talk
Hey,
about
I'm back. Sorry. All right. Sorry, I'm back. So we can go into while loops now, which is our next way of getting more control over our code, which is sort of the theme for this, to be honest. So what a while loop is basically our way of saying, I want to do some code over and over again. Let me do that. So let's look at this while loop. So what it's telling us, let's analyze this code for a sec. So it says we have this integer, I equals 0. And when we're using a while loop or any kind of loop, we like a really easy and common name. Oh, sorry. A really easy and common name is just the letter I. We do I, J, K. Those are just the really common ones, and they're sort of convention. And we have int I equals 0, and while I is less than 10, we say system.println sheep, and then I++. So can anyone maybe take a guess as to what this is going to print out?
Oh, I'm going to guess we're going to get 10 sheep.
Yeah, perfect. So we're gonna, the code is going to look here. It's gonna say, well, I is less than 10. Okay, I is 0. It's gonna print the word sheep, and then I is gonna go up by 1. Then it's gonna jump back to the start. It's gonna check again if this is still true. So now it's say, okay, I is 1. Well, that's still less than 10. So it's gonna print sheep, and it's gonna go over and over and over until eventually, like we say I is 9, it prints sheep, I++, and now I is 10. And then it says, well, is 10 is less than 10? Well, that's false now. So now this thing ends. So that's how a while loop works. It'll keep doing something until this becomes not true. And if this was false in the first place, if I was like 100, this would never happen.
And it is similar to with if statements and all that stuff. We have what we call, again, a conditional. So it is just on the condition that I is less than 10, we're running that over and over again. This is pretty useful because, you know, in other classes, like kids classes, we do things with like different modules, and we see people copy pasting the line over and over again. So they'll maybe copy paste the lines just into outline print sheet like 10 times, but we can just simplify things and make them a little shorter with using loops. While in things like writing, maybe you want longer, you know, it looks cool if you have a lot more. With coding, it is actually really much, it's a lot better for you to have shorter code.
Yeah.
It's more concise and a little bit more compact.
So this is a way you could use a while loop, and it'll let you keep doing something until some condition is met. In this case, we have a slightly different piece of code. You see we have while true, and the first thing that should come in your mind is while true, that's just going to happen forever. That's just a piece of code that is never going to end, which is normally something you don't really want. But this is here to introduce you to the break line, which is something you can include in any loop. So in this case, it'll keep doing sheep, and then when I equals 10, this if statement will happen, and it will break, which means it'll immediately exit the loop for us.
And the plus plus always increments by 1?
Yeah, so yeah, just as a reminder, plus plus just means increase I by 1. So any questions on while loops? All right, so
We'll use them in context, so it'll make, you know,
yeah.
if the syntax isn't clear away, we'll use it in actual programming. So it'll make
we're gonna do like a little guided project right after this, and we can go through it. So the last thing we're gonna show you before, all right, do you want to do this one?
Sure. I was gonna say, yeah. So for for loops, they're kind of like while loops, but they're a little bit, again, a little bit more compact. So while in a while loop, they're mathematically the same. We're declaring the integer I in the first part. So you'll see what's most striking about the for loop is it has for, and it has 3 different sections separated by semicolons. The first section is just instantiating what we use as an iterator, because like Michael said, we have to iterate things to eventually escape the loop. Otherwise, it'll be stuck in there forever, your computer will crash, it'll be terrible. We're instantiating the variable first off, we're saying int I equals 0. The second part is the actual condition. So we're saying, you know, for every single time that I is less than 10, run this code, and then we increment on the very end. So you can actually leave these blank. Like you can say, for int I equals 0, semicolon, blank, semicolon, and then you can have something else. But again, for loops are here so that things are more compact, and you do want to utilize everything that you can with a for loop. It is really powerful because when you see the while loop, it's a couple lines of code, but for the for loop, it is just a simple, very compact statement. And again, this usually works when we say we want to iterate something a certain number of times. Usually while loops work better with things that we kind of don't know. So if we're relying on user input, such as for our next project, we're going to be relying on the fact that the user will keep guessing something. So in that case, we use a while loop because we don't know how many times we want to iterate it. But usually for loops, we kind of have an idea of how many times we want to go for, and that's why we use these for. So they have the I built in, they have the condition built in, and they also have the iterating built in, which is really cool.
Question on the way the system out print line is formatted. Because of where the close quotation mark is, what we'll actually see is the word sheep space NUMBER followed by the digit 1 immediately.
Yes.
Yeah.
Exactly.
No
Perfect.
space.
Uh-huh.
Okay.
Yeah, so Java is super specific when it comes to that string formatting. So there would be no space. Perfect. Yeah, that's exactly right.
Thank you.
So right after this, we're gonna make a game. I think we could just take. Do we have a lot of time? It's 2:50. So AJ, do you think we can do guess my number now, or do you think we can save that for next lesson?
I think what we can do is we'll introduce what it is. We'll have the variable set up just so we have a general idea how to go about it. If people want to tinker after the lesson and try to figure it out, that'd be awesome. But if not, we will run through our solution code for the next time then.
So let's start learning about guess my number. So this is a really, after Hello World, this is usually a really common little app to make to demonstrate knowledge of coding. in Guess My Number, the computer will pick a random number from 1 to 100, and then the user has to try to guess what the number is. So usually the computer gives the player some sort of hint when they guess the wrong number. We could have all sorts of things to add on to it, but for now, we're just going to make a game where the player can guess a number, and it'll be a lot easier and also a lot harder than you expect it to be at the same time. It really teaches you how to do coding.
Can we make one assumption that the random number is going to be an integer, please?
Yes, we'll definitely do.
No, you'll have to memorize every digit of pi to get this game. I'm sorry.
You're not sorry. You're not sorry at all.
Not at all. So let's start getting some setup for it, and we can get going with it. So this is sort of like half guided and half individual. So if you guys have any ideas for how you want to individualize it, put in your own personal ideas for it, or if you want to try guessing some, like how to do some functionality before we even get to it, that's completely encouraged. That'd be awesome.
I'll give a brief demonstration, Michael, or did you want to actually do it? Oh, you have it up. Okay, so yeah.
Yeah, I have it up, and let me just hide all the code from you guys. So if I run it, it would tell me after a very long compile time.
I guess at the end of the session,
Yeah.
I'll run you guys.
What's your first guess? I'd say maybe 50. Too low? Okay, so let's do like 80. Too low? Okay, 90. Too high? So maybe like 85. Too low? 87. So now I know it's 86. It tells me, good job, you got it in 6 guesses. So that's kind of where we're shooting for, a game with that kind of functionality.
So there's a lot of does anyone want to take any guess, like kind of picking apart certain parts? You know, we're utilizing variables, we're utilizing comparisons with Booleans, we're also utilizing loops, if you guys can guess where that is. Does anyone want to take a stab just at any piece of this functionality here?
So yeah, maybe anyone could take a guess on how, how are we getting this input? How are we continually doing stuff? How are we, any ideas?
Well, if I may, it seems like first you're going to have to initialize some variables. Then, without getting too specific just yet, because I'd have to check my notes, you're going to output what's your first guess, because you say first guess. If you just said what's your guess, that could be in the loop as well. But initially, that one's outside it, and then. And then I'm going to have to go to my notes.
That is a really good starting out point.
Yeah.
Usually people don't guess that. Oh yeah, usually people don't recognize that the first statement does have to be outside of the loop. So I'm really glad that you caught that. So if we start like a new REPL, we can start initializing some variables then just to have like a layout. And then I guess that will be kind of time. So again, if you want to start out with loops and those kind of things on your own, you can do that.
Do you have a clean REPL, AJ, or do you want me to do it in this one?
We should probably use a clean one.
All right, so could I just delete everything in here? Or?
Sure, yeah, that works.
Yeah.
I don't know why, but it's not connected with me. Like that's why I wasn't using that one. I'm sorry, that's on me. But
so let's kind of like brainstorm some ideas. So if anyone has any ideas of like just shouting out, what kind of variables and numbers do we need to set up? So we already imported scanner and random, so we have that over here. But we have nothing in our code. So what kind of things do we need to start off?
And please feel free to follow along. So if you have this like split screen and have REPL on this side, we can give you a moment just to set that up also.
So you could say anything out loud or in the chat. Any ideas?
I would want to generate a random number and assign it to the variable. That's the target I'm trying to get to.
Yes.
All right, that's a great start. So you could have a random.
Call that number an integer?
Yes, it would be an integer. Very good.
Yeah. So we could have random equals new random. And we can make our integer. So integer my number equals,
Do you want to call it mystery number just so that we get the variable names kind of?
so mystery number equals rand.next int, and we're going to the number 100. But remember that if we do next int 100, that's going to give us a number from 0 to 99. So we actually want to do +1 here.
Okay. Mm-hmm.
Because remember, random always, if you don't include like all the special stuff, random will always start at 0 and always end at the number 1 below this.
Okay.
So, okay, we
Why
have
don't we just define it until 101?
Hmm?
Why don't we just, in the parentheses, say 101?
So that's a good point. That'll give us a number from 0 to 100. And if that's how you want to do the game, that's cool. But I think we have here is a number from 1 to 100.
Okay.
Yeah. But that's a really good point, though. If you're going to do 0 to 100, that'd be perfect.
Okay.
And a question, the way you have identified mystery number, that's an example of, I think last week you called it camel case.
Yeah, perfect. So
Okay.
camel case, where you start with a lowercase and you do each consecutive word with an uppercase.
Okay.
Oh, we went over naming conventions. That's cool.
Yeah.
I hate using underscores for variable names. That is my one naming
Yeah.
pet peeve, but it's also very valid. So.
Mm-hmm. Underscores are a little painful to read, but yeah, it's fine. Anyway, it works. However you want to name it works, honestly, as long as you understand what you're reading.
So we have our variable set up. I guess the next part would be interacting with the user maybe. So what would we do after here?
Is it print?
Yes.
You have to print the prompt.
Mm-hmm. So
Go system. Print. We can tell the user, welcome to guess my number. And as we said, it's their first guess. We could say, what is your first guess?
And like Kevin said, that's the outside of the loop. So we haven't gotten to the loop yet, but it is right outside there.
So now that we've told them to enter their first guess, we have to read their input.
Mm-hmm. So I'd love to read their input, but we don't have a scanner yet. So we would have to we're going to make a new scanner. We have scanner scan equals new scanner. And it has to have system.in. And now we could say, so it definitely makes sense to get their input, but another thing we have to think about is, let's get their input. So let's say scan, or let's say int guess number equals scan.next. So now we have their first guess, okay. But we have their guess, and we have to ask, when do we want to start looping our code?
Now.
And also, how are we going to check if that guess number is our mystery number? So we're actually at 3 o'clock.
Now.
Huh?
Wouldn't the next step be the loop?
Yes.
Yeah, the loop.
But
So
the trick here is the condition, because we kind of don't know the number of times we want to iterate. So I guess we can set up the loop for now, and then we can just break there. Yeah.
So yeah, this will be the last thing we do. So we make our loop, and we can think, what should our condition be?
So inside of our loop, first we can figure out what is inside of our loop so that we know what we want to run, and then we can figure out, oh, when do we want to stop running this thing?
Yeah.
So
Let's think of our condition, and then we can call it a day because it is 3 p.m.
I would say it's not equal to the random number.
Perfect. So if we do guess number is not equal to the mystery number, then we do our loop.
Yes.
Awesome. So I think we're all set up for next week. We have everything ready. We're good to do everything. So I think this is where we can call it a day. If I'm gonna stay up for like 5 more minutes, so you guys could finish writing notes, ask questions, copy stuff. But thank you so much for coming, everyone.
And feel free to tinker around with us after the session.
Say your last again, AJ.
Oh, I just have to say continue to work on this after the session if you'd like, and just try to tinker around with it if you want to figure it out.
Good.
All right, thank you, everyone.
Thank you so much, everyone.
Thank you, folks.
Where
Good class.
where can we get this?
Thank you. REPL, so REPL is on your
No,
back.
the REPL I know, this
Yeah.
presentation.
Oh, the presentation. So I can send out the slides for it with Shanae. So were you signed up for it? I can let the librarian know to send those out also. So we can share these slides with you.
Thanks, that'd be great.
Awesome.
Quick question. For the random and the scanner, is that practice to always put those up at the top of the code? Like if you realize you need something, do you always put it back up at the top, or do people ever insert it?
Right.
Yeah, so it's good practice to, I'm sorry, AJ. Yeah.
You do want to put it before you use it. So you can put it wherever, but yeah, for the most part, people put it at the top. But again, let's say you need random only in one function. So we haven't gotten to that yet. But if we have this whole other block of code and we don't need random for anything else except for that one block, you can also import it just for that area there. Yeah, for the most part, we will just be sticking it at the very top.
Mm-hmm.
Okay, thanks.
Oh, I mean, I guess since we have a little time, I'm gonna probably go over this again next week, but this doesn't really matter in this code because by the time we stop needing random and scanner, we've already ended the code. But say you're in some amount of code and you only need rand for that little part of it, like you said, what you should do is you should write rand.close. I think that's it in Java, right? I think the right thing in Java. What you're telling the computer here is I've stopped needing this random. So give back, like end it, give it back all the memory that it's supposed to have. I know for a fact it works with scanner, so let's just do scan.close. Either one works. This is just telling the code, I'm done using this, give it back all the memory, like I don't need this anymore. Why this is important is because, and again, this goes back to memory issues, which aren't really a huge problem because we have our modern processors that are like way more powerful than anyone would have expected back when Java was made. But you want to close stuff to avoid having issues with memory and having issues with space, because that could cause an issue if you keep making scanners and never closing them.
Okay, because does it keep all the information that it's scanning in memory?
Yeah, it pretty
Runs
much
the risk of it getting too large?
Yeah, it takes up memory. It takes up memory, and it also just has this space, like its own space. And it isn't a problem if you close them, because then it releases the space that it took up. But if you keep making them and if you forget to close them, then it'll take up a lot of space. If you make like 1 million scanners,
But like
which in a big project you might end up doing. Like if you end up making like a huge game where you have to keep making scanners and randomizers.
But it's not the end of the world.
Yeah, it's not the end of the world though, because like this is just like a little piece of code. Yeah. I'm just actually double checking myself on this real fast.
I've never actually closed a scanner or random, but I guess, I don't know, it makes sense. Yeah, again, it's not the end of the world. I've never really done it, but. Yeah.
Okay, yeah, so you do close scanners, I'm sorry.
That's cool. I learned something new today too. All right. With that, unless there are any other questions, you are free to leave. And again, thank you for coming today.
Thanks a lot.
Thanks, folks.
Take care. Bye-bye.
All right.